Ladies and gentlemen, once again, this is Fraser Nation. We've come to a point where we need to review some things. I have on your screen the fall final practice study guide for you. I'm going to go through all these problems. I'm going to try to drop a little bit of wisdom and knowledge on you. Um, stuff that you don't have written on this study guide, then, I would go ahead and write that stuff down. So, like I said, this is my own personal study guide. So I'm going to go ahead and put my name on it. My name is John Q. Okay. Um, my name is John Q. Student. And, today I'm going to kind of just write and then scroll, write and scroll. But when I scroll, I'm going to have to erase some things. So just make sure that you're paying attention throughout this whole video, and it should make a little bit of sense to you. So first and foremost, determine the coterminal angle between 0 and 360. So basically, I try to drop a little bit of knowledge on you throughout the study guide. Here's my first little bit. Whenever you're trying to find a positive or a negative angle that's coterminal with what I gave you, so in this first one I gave you 429, you either got to subtract or you got to add until you get between 0 and 360. Okay? So 429 is not between 0 and 360, so I'm going to have to subtract 360 from this, and let's write this down. 429 minus 360. And once you put that in your calculator, you'll see that that is 69 degrees, okay? Which is between 0 and 360. And you have to do that for each one of these. If it didn't work one time, you'll have to do it again, like 1039. You would have to do 1039 minus 360. That's not going to get you between 0 and 360, so you're going to have to do it again. You would have to do it two times. So 1039 minus 720 is going to be 319. Okay? 319 degrees. For this one right here, you would have to add 360 three times. So if you did negative 955 plus 360 plus 360 plus 360, then you would end up with 125. And finally, negative 2, you only just have to add 360 so that you are between 0 and 360. So negative 2 plus 360 is going to get you 358 degrees. Okay? To find the reference angle, sometimes you need to find the reference angle, the coterminal angle first. So sometimes you need coterminal angle, okay? These angles down here also have to be between 0 and 360. That works for this one, but these other three, it does not work. So first of all, you need to find your coterminal angle. 139, this is in quadrant 2. Quadrant 2 says that you have to take 180 and subtract from the angle. So this is going to be 180 minus 139. So the reference angle here is going to be 41 degrees. Okay. Negative 300. That's not between 0 and 360. So first and foremost, I'm going to have to take and add to both of them. So you get 60. 60 is in quadrant 1. So all it is just that angle itself. So the reference angle here is going to be 60 degrees. 550, you would have to take and subtract until you get between 0 and 360. So this is 550 minus 360, and you're going to get 190. Okay? 190 is in quadrant 3. So quadrant 3 says that you have to take your angle and subtract 180. So this is going to be 190 minus 180, and that's going to be 10 degrees. Okay? And finally, negative 800. I'm not going to go through the math, but negative 800 The coterminal angle is going to be 280 degrees. Okay, that's your coterminal angle, which is in quadrant 4. Quadrant 4 says you do 360 minus your angle. So this is 360 minus 280, and you're going to get 80 degrees back. Okay? So this is your final answer. So like I said, give yourself a minute, pause the video if you need to write this stuff down. I'm going to clear it now so I can scroll down. Okay, so with some of these right here, you're going to need to know how to solve right triangles for x. And I'm going to say right now, and let me go ahead and type this bad boy. Oh, no, that's not what. Well, yeah, we can use that. Let's put this in red. Put that in red. Put calculator in degree mode. Okay, you're working with degrees here, so sometimes you're gonna have to change your angle mode inside of ooh, what did I just do? You're gonna have to put your calculator in degree mode. So it's either gonna be shift setup or it's gonna be control setup. But you need to have your calculator in degree mode. So let's go ahead and call it shift, then set up menu, and then change angle to degree mode, or it's going to be control, then set up. Okay. Okay. Once you do all that stuff, everything should be pretty straightforward. Right here, solve a right triangle for x. So here's my x right here. Okay. And the very first thing we want to do after putting our calculator in degree mode is, well, here's my angle, 53 degrees. And the easiest thing is always find out what your hypotenuse is, which is across from the right angle. So my hypotenuse is 15. The next easiest thing to do is, if I'm talking about 53, the side opposite of it is going to be across the triangle. So this is your opposite. And in this problem, you really don't need adjacent, but I'll write adjacent down. It's the process of elimination. So whatever you have left. So we have opposite, we have hypotenuse. We're going to have to use sine, which is opposite hypotenuse. And remember, you put your angle there. So right here, it's going to be sine of 53, which is equal to the opposite, which is x, divided by the hypotenuse, which is 15. And then when you have to multiply both sides by 15. So let's play plus 15 here. Times 15. And times 15 here. And so now your new problem is going to be 15 sine 53. And then when you plug that in your calculator, and hopefully your calculator is in degree mode, then you shouldn't have this degree right here. That shouldn't be there. It should be 11.97, or you can just put 12. Okay, so basically, does that make sense? The hypotenuse is 15. This is your longest side. So obviously, my x should be 12. So this side right here should be 12. Over here, we have two angles. And let me go ahead, clear that out. Because we're going to use this stuff right here. That's how you find your angle measure. You see these thetas right here. So what we have to do is we have to use find x first. Okay. So from x, we know the opposite We don't have opposite. We don't talk about opposite, so we don't need it. The hypotenuse, which is 20, they gave us that. And then process of elimination, 13 is going to be our adjacent. So we should be using cosine. And instead of cosine, we're going to be using inverse cosine. So this is the one we're going to use. So x is going to be the cosine inverse. Okay. Cosine inverse of 13 divided by 20. And when you plug that in your calculator, you should get 49.46 degrees. Okay? Now, there's two ways to go about finding y. You can either do 180 minus 49.46 minus 90, because in a triangle, if you know two angles, you can subtract them and find that third angle. Or you could do the opposite. Okay, so let's do some erasing here. When we're talking about y, the hypotenuse stays the same, but now the 13 is across from y. So this would be your opposite. And then opposite hypotenuse, you would use inverse sine. So this could be inverse sine of 13 over 20. Either way you go, you should get 40.54 degrees. Okay? And then finally, this one has proven kind of difficult for some of my people. The law of sines. The most important thing that you want to remember here is that they gave us both the angle B and the side across from B. So remember, when you have a big letter like big C, this is little c right here. When you have big A, you have little a. When you have big B, you have little b. And in this triangle, they gave us both big B and little b. So we're always going to want to use this one right here. Okay? Right here, the very first thing that's important is you want to find your third angle. So this is going to be 180 minus 50 minus 42. So your answer here is going to be 88 degrees. So to find little a, which is right here, you want to do, and I don't have any room here, so let's go ahead and transfer. And so we have here sine b over little b, and we have sine a, big A over little a. So you have sine of 88 over little a, which is equal to sine of 50 divided by 11. And when you cross multiply, you get 11 sine 88 equals a times sine 50. We want to get rid of this sine 50. So this is going to be 11 sine 88 divided by sine 50, because I divide both sides by this, and you get a. Okay, and then when you plug this into the calculator, actually, let's go ahead and put that back in. When you put that in the calculator, you're going to get 14.35. Okay, so this is going to be 14.35. Okay, and then the final little c, okay, we're going to use this one, and we're going to use sine c. So let's go ahead and put that here. So I have sine b over little b equals sine big C of little c. Again, just plug your numbers in, cross multiply. So we have sine 88 over 11 equals sine 42 over little c. Cross multiply, you have sine 88 equals 11 sine 42. Divide both sides by sine 88 so that we can cancel out. And we have C, which is equal to this expression. And when you plug that in the calculator, you're going to get 9.6. Okay? 9.6. So give yourself a chance to go ahead and write that in. I'm going to erase it, and then we're going to go ahead and move on. To find tangent, if cosine is equal to this, I taught using this kind of little acronym, something you just kind of have to remember. Sine is y over the hypotenuse. Cosine is x over the hypotenuse. So sine is y, cosine is x, and tangent is the mix. So tangent is y over x. So I want y and x. And then it says quadrant 2. So remember your quadrants. If you don't remember your quadrants, they go 1, 2, 3, and 4. So I'm going to draw my triangle in the second quadrant. So here's my quadrant. Here's my triangle. And if it's cosine, cosine means I have my x and I have my hypotenuse. So it says negative 5 over 13. So my x, here's my x-axis, remember that. Here's my y-axis. And here's negative 5. Okay? Let's go ahead and try to be a little neater about it. Here's negative 5. My hypotenuse has to be 13. And when you have hypotenuse equals x squared plus y squared, once you do that, once you plug those two numbers in, it should be 169 equals 25 plus y squared. So basically, y is going to be equal to 12. So here is 12. So I drew my picture. Okay. Here's my x. Here's my hypotenuse. I have to solve and figure out what that third side is. So tangent is y over x. So if I have y over x, then I have 12 over negative 5. Okay, so basically it's to figure out if it's y over the hypotenuse, x over the hypotenuse, or if it's y over x. Right here, given the point x, which is negative 4, y, which is negative 3, find sine. So remember, sine of theta is going to be y over the hypotenuse, okay? So you have your x, you have your y, and once you do the Pythagorean theorem, you're going to find that the hypotenuse is equal to 5. It's a positive 5. So this is going to be equal to negative 3 over 5. Okay? You could always plug these in your calculators. I kind of do them by hand now, but if you put this in the calculator and you have to use parentheses, put this in the calculator, you're going to get pi over 8 in one parentheses, and in the other parentheses, you're going to do 180 over pi, okay? You plug that in the calculator, you're going to get 10 degrees, okay? Right here, same thing. Put this in parentheses. Multiply by 180 over pi. And you're going to get, I should have had this memorized already. You're going to get 100 degrees. Right here, you multiply 257 by pi over 180. And you're going to get 4.5 radians. Okay, you don't really need in terms of pi. I'm comfortable with just the decimal. And then when you multiply this by pi over 180, then you're going to get negative 5.3 radians. Okay? Give yourself a little time. I'm going to clear this out. All right. Right here, first and foremost, you need to realize that one revolution is equal to 2 pi. So every time you go around, you get 2 pi. So if I have 93 revolutions, then it's going to be 93 times 2 pi. Okay? And then here, there's two ways to do this problem. Okay? What's its angular velocity? Here you go. So you can either do 186 pi, okay? Or you could just find the decimal, which is 584. And remember, when you're at the end, you can't round until the very end. So this is 584 times 0.3362335677. Okay? So to do this problem, you can either do 186 pi over 9 seconds. So I can do 186 pi over 9 seconds. Or I can do my whole decimal. So this is 584.3362335677. All that divided by pi. So it depends on how comfortable you are, but once you plug one of them in, you will see that the answer here is supposed to be 64.93. Okay, that's the answer. Number 9, what's the angular velocity per second? And this one says per minute. So first and foremost, and I'll probably have this on the exam, when you say diameter is 2 times the radius. So the radius here is equal to 17.5 feet. Okay, you need to remember that. 17.5 feet. So when we talk about angular velocity per second, either it's going to be nine revolutions per second. So we would do per minute. So we would do we would find out how many radians that is per second. So we would do 9 times 2 pi divided by 60 seconds. Okay, so that would be 18 pi divided by 60. And so when you do 18 pi divided by 60, so let's go ahead and plug that in. 18 pi divided by 60, this says 0.94. Okay, that will be your answer. Okay, because here we got to change this to radians. Okay, so that's where we get 18 pi, and then since it says per second and this is per minute, we have to divide by 60 seconds. Okay, and then linear velocity is when you take your angular velocity. So look, that's why I have an arrow right here and right here. I've just figured out what my angular velocity is, and all I have to do is multiply it by the radius, which is 17.5. So if I did 17.5 times the angular velocity, which is 0.94, I'm going to get approximately 16.45. Okay? Questions? Concerns? Okay, clear this out. We're going to keep moving. Let's see. Choose choose the equation. If I have A sine K theta, the one thing you need to remember here is period is equal to 2 pi divided by K. So it says that my period is 9 pi, so I have 9 pi is equal to 2 pi over K. And when we cross multiply, I'm going to get K 9 pi equals 2 pi. And so when I divide both by 9 pi, this is going to be K equals that stuff. And then you could take and divide or cross out the pi. So here's a pi that's canceled. Here's a pi that's canceled. And so K is 2 over 9. So once K is 2 over 9 and you already know what your amplitude is, then it's going to be Y equals your amplitude, which is 5. Put your sign. And then what's your K? 2 over 9. So here's 2 over 9 theta. Okay? So there's your answer. For this type of problem, I realized on some I wrote this 2 times, on others I didn't. The ordered pairs, okay, where you subtract your x's, your y's, and your z's. Okay, so if you don't remember, here's my x, here's my y, here's my z, and then same thing here, x, y, and z. Okay, so my x's are going to be 10 minus 6, comma, so here's my x's. My y's are going to be 5 minus a negative 2. Here's my y. And then my z's are going to be negative 3 minus 4. Okay, here's my z's. So 10 minus 6 is going to be 4. Okay, 5 minus a negative 2, that means that they become positive. So this is a positive 7. And then negative 3, negative 4, that's going to be negative 7. Okay? So here's my x, here's my y, here's my z. And the shortcut is the distance formula. I've already did x2 minus x1. I've already did y2 minus y1. And I've already did z2 minus z1. So I would have the square root of 4 squared plus 7 squared plus, and then remember to put this in parentheses, negative 7 squared. Okay? So this would be in square root 16 plus 49 plus 49. You put all that in the calculator. Make sure you use parentheses for that. And you're going to get 10.7. Okay? 10.7. Cross this out. It says write a new vector B and write a new vector C. When we talk about 2B, we're talking about 2 times 3, comma, negative 8, comma, 4. And we're talking about 3. And then we have negative 10, negative 4, 1. So right here, my new vector would be 6, negative 4, and 8. And then this one would be negative 30, negative 12, and 3. And then it says 2b, so here's 2b, here's my 2b, 2 vector b, and here's my 3c, and I'm supposed to subtract them. Okay, so 6 minus a negative 30. Okay, so that's 36. Negative 8 minus, I'm sorry, that's not a negative 8 right there. Let's change that. That's supposed to be negative 16. So let's put a 16 right here. Negative 16 plus 12, that's going to be negative 4. And then 8 minus 3 is going to be a 5. So here is my 2, vector B, minus 3, vector C. Okay. I'm going to go up back to the top where I was supposed to graph. So the first one I'm going to graph is cosine theta between 2 pi and 4 pi. So remember, I'm going to make a t-chart, use theta instead of x. So here's theta, and here is y equals cosine theta. Okay, so I have my theta, I have my x. So this is going to be y equals cosine theta, and then this is going to be my here's a break. This is my theta axis. Okay, so place the first number first slot, place the last number in the last slot. So this goes 2 pi, this goes 4 pi. Okay, average. So you're going to take and add these two and divide by 3. I'll divide by 2, so add and divide by 2. So what number goes in the middle of 2 and 4? 3 pi. And then you're going to do the same thing. You're going to average. So I have 2 plus 3, which is 5 pi. 5 divided by 2 is going to be 2.5 pi. And then this one is going to be 3.5 pi. So I've made a t-chart. I put my first number first slot, last number last slot. I averaged it out. I averaged my second and my fourth slots. And now I have to calculate my value. So when I put this in the calculator, it's going to be y equals cosine of 2 pi. Okay? Put that in parentheses. And y equals cosine 2 pi is 1. Y equals cosine 2.5 pi. And that's going to be 0. And then when you go on, when you keep doing that, you're going to get these numbers. Okay? So that means you're going to go up to a 1, and you're going to go all the way down to a negative 1. Okay? And so, filling my graph, I'm using a theta axis instead of x axis. So here's my graph. So here is 2 pi. Here's 3 pi. Here's 4 pi. You can fill in the other ones if you want. And so it's 2 pi, which is 1. Here is 2.5, which is 0. 3, which is negative 1. Here's 0. Here's positive 1. And then number 7, connect with a smooth curve. And there's my smooth curve. Okay? So that's how you do that one. Okay, give yourself a second. I'm going to erase and use the same graph. Okay, so again, I'm going to do this one now. Okay, so I'm going to do this one between 0 and pi. So made a t-chart, I used theta. So y equals 5 cosine, and then in parentheses 2 times theta. Okay. Here's 0. Here's theta. And so what's half of theta? This is going to be 0.5 theta. Okay. When you say 0.50, what's half of 0.50? half of 50 cents is going to be 25 cents. So right here is going to be 0.25 pi. And then right here, what's half of this? So I have $1, I have 50 cents, so in half is going to be 0.75 pi. So I put my first number first slot, last number last slot, I averaged, I filled in my second and fourth. Now I have to calculate. So this is going to be 5 cosine, and then 0. And then that's going to be 5 cosine 2, and then put this in parentheses, 2 times 0.25 pi. This is going to be 0. I have 5 cosine 2 times 0.5 pi. This is going to be negative 5, 0, 5. So that means you're going to go up to 5. So this is y equal, here's my y, and then here's my theta. I'm going to go down to negative 5. And so here's my 0. 1, 2, 3, 4. So here's 0. Here's pi. Here's 0.5 pi. And so, and then you just follow it out. Fill in your graph. So 0.5 is supposed to be a negative 5, so there you go. Here's that. Here's that. And of course, like I said before, connect with a smooth curve. You were supposed to change your calculator into radian mode. I kind of forgot to tell you that. You should see that on your assessment. So let's go back. Lastly, here's some graphing. Do you need to convert degrees to radians? If you'll notice, our graphs are both in degrees. So right here, for example, I need to change pi over 4. And how do you change to radians? Well, you multiply by 180 over pi. Put that in your calculator, and you will see that that's equal to 45 degrees. One thing about the negative, when you have a negative r, okay, here's your r and here's your theta. When you have a negative r, you have to use opposite angle, or you have to use opposite theta, okay? So here's 45, okay? But since the r is negative, I have to use the opposite angle. So the opposite angle is right here, 225. So I'm going to have to use 225. So use 225 degrees. And it says -2, so here's my second circle. There's my dot, and let me put a B right there. This one should be easy. Use the theta, which is 90 degrees, and here's 3. So there is my A. Give yourself a second to copy that out. Clear. Scroll down. 150. Okay, but remember your r is negative. So since your r is negative, we have to use the opposite angle, which is 330. So I have to use 330 degrees. And so here it is right here. That's C. And then finally, 2 pi over 3. Put that in your calculator. Times 180 over pi. Once you do all that, you're going to get 120 degrees. So go around, here's 120, and then it says 2.5. So I have to use the circle between 2 and 3. So here's 120 right there, and that would be point D. So we went through your study guide. It would be a good idea to bring your study guide with you with some of the work attached to it. If you need to, go back in your notes, study, and good luck. Good luck. This is Fraser Nation signing out.